The world champion of precision. Machine tools for 5-axis machining are confronted with a special challenge. The manufacture of precise workpieces presupposes a high spatial accuracy of the machine tool. Compared with 3-axis machining, 5-axis machining makes it possible to attain unequivocal economic advantages. However, it also involves considerably more complex feed movements, because in addition to the linear feed axes, the rotational axes have to be moved simultaneously and with high accuracy. The deviations between the ideal and actual behavior of a feed axis increase with growing paths of traverse. This occurs because, depending on the machine kinematics, the linear feed axes have to perform additional movements to position the tool, the so-called compensating movements. This increases the paths of traverse and the feed rates of the individual motors, and often detracts from machining accuracy. Positioning accuracy depends on position measurement. If the axis positions are measured only by rotary encoders on the motors, position error results. This results from thermal shifts in the ball screws and from transmission errors in the gears of the rotary axes, possibly leading to dramatic flaws on the workpiece, especially if produced with 5-axis machining. Thanks to the precision of HEIDENHAIN linear and angle encoders, positioning accuracy and repeatability are increased enormously. Semi-closed and closed-loop control. The method of position measurement by rotary encoder on the feed motors is called semi-closed loop control because mechanical error in the transmission mechanism cannot be compensated by the motor's control loops. The positioning accuracy and repeatability values of feed axes can be vastly improved with the use of precise linear and angle encoders. Since the axis positions are no longer measured on the motor, but rather directly on the linear and rotary axes of the machine, this is referred to as closed-loop control. A soccer ball as proof for maximum accuracy. The advantages of measuring positions via linear and angle encoders from HEIDENHAIN become obvious when this soccer ball is considered. The ball was produced in 3 machining steps from a workpiece blank shaped on a lathe. 3-axis milling of the pentagons with vertical paths and inclined cutter. Likewise, 3-axis milling of the hexagons with horizontal paths and inclined cutter, and 5-axis milling of the seams. Thanks to the precision of HEIDENHAIN linear and angle encoders, the intersection of the seams is met exactly with each cutter movement.